Okay, I think we have got problems with some webcams. My webcam and the webcam of Dogukan isn't visible. Yeah, we will start anyway. Dogukan is there. My webcam doesn't show anything. Okay, it doesn't matter. Welcome to today's webinar. The topic today is Web Service and API in RFEM 6. My name is Andreas Hörold. I'm responsible for marketing and public relations in the Dlubal Software company. For instance, the Dlubal website, customer projects, the webinars, etc. I will be the moderator today, and my two colleagues can introduce themselves.
Hi everyone, my name is Doğukan Karataş and I'm responsible for developing and testing web services technology. I will be the presenter and I will respond some questions of you.
Hello, my name is Jaroslav Broš and I'm Scrum Master of the team which is responsible for the development of web service. Today I'll reply your questions and also I'll take a part of the presenting the C# and web service.
Okay, thank you for your introduction. Now you can see my webcam as well. It took a little bit more time, sorry. But now we can switch off our webcams that the attendees can see the full screen. Okay. Yeah, you can ask questions via the control panel on the right side of your screen. You can enter the question here. You can also do audio settings if you say or hear us too loud or too not very loud and so on. Okay, and we will answer you during the webinar. If there are too many questions and we can't answer all questions during the webinar, you get an email afterwards. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, then I hand over the screen to Dogukan. Just a moment.
Okay, thank you, Andreas. Can you see my screen now?
Yes, we see the right screen.
Okay, firstly, I would like to start with a presentation about our new technology, web services and API. This technology offers a programmable interface for RFEM 6 and HTOP 9. If you have little or no experience with coding, no need to worry. I will be explaining every detail step by step. Basically, this service offers a language-independent remote communication with RFEM 6 and HTOP 9. We, as the Dlubal team, are developing comprehensive frameworks to simplify the programming experience. Our frameworks has developed in Python and C#, and scripting in JavaScript is also available. So, what are our topics today? We will look at the benefits and application areas. What are the possibilities and the vision? I will be explaining the main logic behind the technology. I will try to explain what is an API and what is a web service. I will show how to get started and how to install the libraries. Finally, I will show some examples and make a live coding session together to show you the product on work. My examples will mainly focus on Python library. And after that, Jaroslav is going to show you some examples in C#. Okay. Let's begin with benefits and application areas. With the power of web services in RFEM 6, there are lots of opportunities. Programming is an easy way to use the power of RFEM 6 beyond its graphical interface. It is a digitized workflow which utilizes the computational power of your machine over manual procedures. For example, one can create a workflow for parameterized and modular structures like towers, steel halls, tanks, or silos. Or it is possible to run size, shape, or topological design optimization algorithms. The most fun part is ability to communicate between wide range of softwares. Beyond that, one can create their own applications or own plugins on top of RFEM 6. There will be examples which are showing how to make that happen. So what is an API? API stands for Application Programming Interface. It is basically a messenger. It takes requests, translates, and returns responses. It is a communication protocol between multiple softwares or services to interact with each other. To understand the concept better, here is an example. A graphical user interface is the communication protocol between humans and software programs. Most of you are using RFEM interface and give the program some commands with the help of buttons or inputs. Well, in our case, API has the same function between a software to another software. What are web services? Actually, web services is a form of API, and the distinction lies in style and the way of communication. Web services are XML-based information exchange systems. In our case, we are using a HTTP technology called SOAP, which stands for Simple Object Access Protocol, to make this connection happen. To use this connection in structural analysis and design, frameworks which are prepared by our team is serving a very basic functions, which enables user to give RFEM some commands and get responses. So what's the difference between COM and web services, and why we have changed our technology? Well, RFEM 5 is a native Windows application. It only runs on Windows operating system. RFEM 6 is a platform-independent software which compiled on Windows, Mac OS, and Linux. COM technology was a Windows feature which runs on the Windows only. Another reason for the change is COM has native support for C, C#, and C++ programming languages, which are currently used by a relatively small community. With web services, our product can be used by the majority of programming community. In addition, Python, C#, and JavaScript are easy to learn, and there can be many resources found on the web. Okay, let's get started and take a look at the installation. Firstly, the libraries is stored in our Dlubal repository on GitHub. For those who are not aware of what GitHub is, it is a version management system. It's an open source development. That means it's public and everyone can see the source codes. Even everyone is welcome to contribute this library. There are 3 ways to access our repository. First is, if you don't have a GitHub account, you can download the repository statically as a zip file. The second is, if you have a GitHub account and using git bash, you can clone the repository in your local using bash terminals. The last and the best way, in my opinion, is installing the library in your machine via pip install. The advantage is you can refresh it with the new developments easily, and if you have Python installed in your computer, all you need to do is open the command prompt and type pip install RFEM. When it's done, you can access the RFEM Python library in every path you want in your device. Okay, let me just quickly show you our repository and how to install it. You can see our Dlubal Software account in github.com, and we have repositories here for JavaScript library, Python library, and C# library. I will open the Python library, and here you can go to the RFEM folder to see the source codes. And you can have a look at the unit tests here if you're interested. Also, we have examples folder to show you the examples. If you have some issues or questions, you can go to the issues part and create some questions and issues. If you would like to contribute our library, you can create a pull request and we will review your changes. Also, there is a documentation page here. You can go. And there are some descriptions for all the classes and functions here, all the attributes. You can see the descriptions. Also, we have some examples in our documentation page. You can take a look at the examples. And also there are some add-on commands also. Okay, I'm going back to our GitHub account. As I said, if you want to download it statically, you can go here and download zip. If you want to clone this repository, you can copy this link and clone the repository in your local. For pip install, you can go to pip.org in RFEM. You can copy this link and paste it in your command prompt. That's it. Okay, I think I can show you some examples now. I'm going to open the Visual Studio Code now. I am using Visual Studio Code today as Python IDE, and I'm skipping the part for installation of Python and Visual Studio Code regarding to the timing issues. Let me just quickly show our folder here in basic objects like Node. You can see the source code of Node and see some descriptions. If you would like to go to examples, there are some examples here. I'd like to show you our trust generator today because it's showing the power of web services, I think. And we are interacting with other Python libraries. In this case, we are using PyQt5, which is a powerful library for graphical user interface. And let me just quickly show you. I will split my screen and my RFEM is open here. There is an important thing. You have to check your options in program options. There is an option for web services. You have to enable this, start the server automatically with the application. Okay, now I can run my file. Then immediately you can see our basic graphical user interface for trust generation. There are some trust configurations here. Here are some diagonal configurations, some inputs for geometry, and inputs for cross sections and materials. I can create a model, clicking this button. Now there will be a connection with RFEM6 now. And it is going to create a model and create this geometry. Okay, the model is created. There is a application is logged by connection from an external application, you can see. And my truss is created. If you would like to change the configuration, let me select another configuration for truss and another configuration for diagonals. I'm going to click Create Model again. And my truss is created. I can edit the geometry inputs here. Let's say 8. I'll click Create Model again. And there's a new connection. And the truss is created. Yeah, it's a cool example, I think, and I'm going to show you some another examples. Let me open my new folder. I have prepared some examples for the webinar. Here I have a tank creator example, which is a console application. Takes 3 inputs for creating a still tank. These inputs are diameter of the still tank, height of the tank wall, and height of the arc. If I'm going to run this file, there will be a new model named still tank, and there will be some inputs in the terminal for the parameters. Okay, my model is created, still tank, and my terminal is asking me diameter of the still tank. Let's say it's 12. The height of the tank wall, let's say 6. And height of the arc is 2. I'm clicking enter, and objects is updating. Objects are updating in the RFEM now. And my tank is created. If you would like to edit this script in your needs, you can free to do that and create your own console applications or own graphical user interface. It's that easy. Okay, now I would like to create an example from the scratch, and I will be coding this and I will be explaining every line step by step. Okay, I have created an example here. Let me make it bigger. It's an arced beam with a section IP 200 with the height of 3 meters and the length of 5 meters. And I will create this geometry and create some loading and take the results. Okay. Let me just create a Python file here named arcedbeam.py. Okay. Now the first thing I have to do is I need to import my libraries. I will begin with init model, which contains the model class. Model class is important because it's initializing the connection with RFEM6. Okay. After that, I need to calculate all function from init model. I will be explaining these functions in the code. The second thing I have to import is the node, because I want to create some geometry. I will import my node from the basic objects. Node, okay. I need to import my line because I would like to create an arc. I'm importing the line class. Then from the basic objects, I would like to create a member. So to create a member, I need a material and section. I will first take the material, then the section. Okay. And finally, the member, of course. I know after the geometry, I need to create a support. So I need a fixed support in nodal support. I will go to types for nodes and nodal support. I'm going to import the nodal support library. Okay, I know I need some more classes, but I will go back and import them when I need it. Now I would like to begin coding. The first important thing is create the model class. I'm typing model, opening my brackets, and I can immediately see the suggestion box in VS Code. There are some attributes and default values. So what does that mean? New model. If you would like to create a new model, you have to pass first attribute as true. If you would like to edit an existing model, you have to pass false. If you have multiple models opened in RFEM, but you would like to edit one of them, after false, the second attribute is the model name you would like to edit. So RFEM would know which model to edit, right? Okay. But in this case, I would like to create a new model, so it's true. And I have to pass a model name, let's call it arced beam. This line is going to create a connection with RFEM. After that creation of the model class, I need to tell the model I'm going to begin the modification. It's under the client model service, and I'm typing begin modification. Opening the brackets, there are no attributes, and when I'm done, I need to tell I have finished my modification. So I'm going to type finish modification here. Okay, I can place all my codes between these two lines. I will start with the creation of the geometry. So I'm creating my node. I'm typing node, opening my brackets, and I can see the suggestion box here. The first attribute is the node number. The second is X coordinate, Y coordinate, and Z coordinate. So it's the first node, so node number 1, and it's the 0, 0, 0 node. My first node is. And the second node is, the node tag is 2, and X coordinate is 5, Z coordinate is 3, and Z coordinate is -3. Yeah. Okay, since I have my nodes, I can create my arc. I know arc is under the line class. I'm typing line. I'm using the dot notation to see types of lines. So there are some arc, ellipse, and parabola. And I'm going to use the arc here. I'm opening my brackets and see the suggestion box here. The first is the line number. It's the first line. The second is nodes list. I'm going to create a list here. It's node 1 and 2. And the third is control point. Control point is useful for controlling your radius in arc. I'm going to select a relatively middle node. It's 2, 0, and -2. Okay, you can see there are other arguments actually, but they all have default values and I don't want to change them, so I will leave it as it is. It's enough for me. So after the creation of line, I can create my material. I'm typing material, opening my brackets. I'm following this suggestion box again. This is the first material, and the name is S235. After that, I will create my section. The section tag, it's the first section, and the name of the section is IP 200. And I need to assign the material, so I am going to assign the material 1 in this section. Okay. Since I have the section, now I can create my member. I'm typing member, and using dot notation, I can see the types of members. I'm going to use the beam, opening my brackets, and this is the first beam. Okay. Oops. This is the first beam, and it's starting from the node 1 and end of node 2. And now I have to select my members section distribution type. It's actually a class and enumeration item in our library. So I'm going to type member section distribution type, and using dot notation, you can see the types of section distributions here. I'm going to use the section distribution uniform. And the next is, I'm following here, the member rotation specification type. I'm using my enumeration items here using dot notation, and I'm going to select the rotation via angle. Okay. The next is rotation parameters. I don't want to rotate my member, so I'm going to pass 0 here. And the next is start section. It's starting with section 1, and section is the same. And I can assign this member to a line, and I have my arc here, which tag is 1. So I'm going to say I'm assigning this member to the line 1. So my member is ready. I would like to assign my nodal support also. I'm going to type nodal support, opening my brackets. This is the first nodal support, and I'm going to assign it to the node 1. And the third attribute is nodal support type, which is an enumeration item also, type. And I'm going to select fixed nodal support here. Okay, this code should create my geometry. Let us check if it's done or not. I'm going to run this file. There will be a new model named arced beam. And you can see here the connecting to server. So after that, the application is logged by external applications. Okay, you can see arced beam model is created. There is a material, section, 2 nodes, and the line type of arc. Okay, and my arc has created here with the IP 200. After that, I can assign some loads in this model. I'm going to make it bigger. As you know from the RFEM, to assign some loads, you need to have some static analysis settings and load case. So I'm going to import them now from the load cases and combinations. And there is static analysis settings. I'm going to import static analysis settings. From the same library, I'm going to take the load case. Then I can define some loads. I'm going to choose the member load here. Selecting the member load. Okay, I have imported them. So I'm going to assign my static analysis settings here, and using dot notation, I can see the types of static analysis settings. In this case, I'm going to select the geometrically linear. Opening my brackets, this is the first static analysis settings, and I have to give it a name. Let's call it linear. Then the load modification, I don't have to assign something to the other attributes. We can leave them as it is. Okay. I'm going to create my load case now. It's the first load case, so the first attribute is 1. The name is, let's call it that. And the other attribute is the self-weight consideration. If you would like to ignore self-weight, you can create a list and type false. That's enough. But if you would like to consider the self-weight, you have to pass true as a first attribute, and you have to specify the direction of the self-weight. So in X, it's 0, in Y, it's 0, and in Z, it's 1. Okay, I have created my self-weight also. Now I can assign a member load. I'm calling the member load class using dot notation, and I'm going to select the false here, and I'm opening my brackets. It's the first member load, and load case 1 I have to assign. I'm following here again, and I'm assigning sorry, it's an integer. Yeah, I'm going to assign to a member 1, and the load distribution, I can go check my enumeration items, member load distribution, and I'm going to select a uniform load distribution here. And the other one is member load direction. You can select the load direction with this item. I'm going to use the dot notation again, and there are some types of load directions. Since it's an arced beam, I would like to select the Z projected here. Okay, cool. The other one is load parameter, and you can see the description. It's just an empty list. Okay, you can think, well, what should I pass on this attribute? It's an empty list. You can scroll down from the suggestion box, and you can see here for load distribution uniform. This is uniform. Load parameter is just magnitude in a list. Okay, then I have to create a list and give the magnitude. Let's say 2000 here. Okay, I have created my loading, so I can say RFEM, let's calculate all. So I'm typing calculate all and opening the brackets. Okay, so this should be creating the loading and calculating the results. Let me run this file. The connection is made again with the arced beam. Mesh is going to generate and calculation is going to run. Okay, let me make it full screen, and you can see our load case has created, named that. Also, we have the static analysis named linear and self-weight consideration here 001. Okay, and you can see the loading by clicking this. You can see this is projected set. And of course, since we have calculated, the results are already ready. You can click the results and you can see the results here in the model. Okay, but for the post process, you would like to get the results out. So I would like to show you some examples how to get the results out. So we have some libraries for exporting results named import export. And I would like to export the results, and I'm going to import some classes here. You have some choices here, export the CSV, XML. I would like to show you CSV. Also, I would like to show you the XML file, the result tables here. And additional, we have a report, which is in HTML context. I'm going to import it also. Export result tables to HTML. Okay, I'm going to export my results. Let's begin with the CSV. I'm opening my brackets, and the only attribute is the pet. Okay, I just want to give the same pet here. I'm copying my pet here, and I'm going to change this name as results CSV. I would like to create some results tables to XML. I'm copying the same pet and rename it as results XML. And finally, I would like to export results to HTML. Okay, I need to give the path again. Results HTML. I have to use the R here. Okay. Okay, let's see what happens. I don't have to look at the RFEM anymore because I'm going to export all the results here. I'm expecting all the results table in this directory. Let's see what happens. Okay, you can see there are some folders created, results CSV. You can see all the results table in CSV format here. Let's take a look at the analysis summary. You can see the sum of loads or reactions, deformations, and all the things here. If you would like to work with the XML file, you can take out the XML, which is containing all the result data in an XML folder here. And the final one, if you would like to see your results in a table view, you can go to index.html, open with live server. You can see your result report in HTML file. All the reports are ready here. And you can see we have a logo here, or we have a table configuration. You can go here, HTML styles, or in index.html and change your icon, change your workflow. You can modify this HTML creation, whatever you like. I think that's all I can show you. And now I would like to hand over my colleague Jaroslav for the C# examples.
Okay, thank you, Juan. I will show my my screen. Okay, so just reshuffle it a bit. Okay, so I will start with the same entry point as Dohu did, because what I would like to present, that's publicly available also in our company GitHub. Here I'll be using the code which is stored here in the repository called Dlubal C# client. And here you can download the code in the same way as Doku showed you for the presentation related to Python. What I would like to do is to just show you how does it look if I will download it. So I have an example which is called Cantilever, and if you will open it in Visual Studio, it looks like this. There is just one CS file which contains all what we need. This file is mainly related to the options that we could use, the library for RFEM, or I can use also the library for Erste, because there are some differences mainly in the definition of lines or surfaces, as surfaces are not available in the Erste application. But this example covers just a simple cantilever beam. What's quite different in comparison with Python is that C# library, as it presented here, it's automatically generated based on WSDL language. So all the types or operations from the SOAP are mirrored into the classes and also the methods in a C#. As it is automatically generated, you need to do a bit more than in the case of the Python, because the Python is, let's say, human or written by human. What we need to do, it's to know the endpoint where we would like to be connected. That was also presented by Dohu, that you need to go here to the options, program options, and enable the start server automatically with the application. Here also you can see that there are some server port range, which is from 8081 till 8089, and that's exactly the URL address which I'm using here. So that's URL I'll be running my application on the local host, and then there is a port 8081. It's so-called application port. That's the access to the application. What I still need to have or to create it's some basic HTTP binding where I'm setting some timeouts and all the stuff around. So if I would like to use our library, you need to have some references and also the using for our presentation. I will use the connection for the RFEM. So the application client, that's equal to the RFEM application client, and also the model client, which represents the access to the model. That's from the RFEM model client. There are some differences in the objects and in the method, as I already mentioned at the beginning of my speech. So here, let's jump to the main function, but I will handle all the stuff around my programming in the C#. So what I need to do is to create a new application client where I have two parameters. The one it's address where I would like to be connected, the address of the RFEM 6 server or Erste 9 server, and also some binding for it. And then if I have an application created, then I will have an access to it. What I would like to do, it's also that I will just split my screen, and then I will show you what's going on in the case of the things which I will do. So I will run my example in the debug mode. So let's try to navigate me through it. So I have a console application where I will have some outputs also. I will just close this. So here I am, and if I will step over, so I have connection to my global RFEM application. Here I can also ask some information about the application. Here in the console, you can see that the name of the application which I'm connected to, it's RFEM 6.02.0008 in English. That's a basic information about the application. What I will go to do now, that's I would like to create a new model, which name is my test model. So I have a name, and I can use a method from the application, which is called a new model. If I will run such a function, then on the background here you can see that I have my test model created. I will connect to my test model because what I received as an output from a function, that's the URL of the model. I do exactly the same which I did also for the application. So I use the model URL and the binding. I will reset my model that currently it's empty and it's locked, as in the case of the Python. And here I do exactly the same what Doku did during his demonstration. So firstly, what I need to do is to define some material. So I have a class material with the properties where I will use just no, which is the number of the material here in a table. So it's material number and also the name. If I know the exact name in the RFEM, I can use it as it is here. So I will do it here. What I would like to do is to create a rectangular section. So I'm using the class for it. I'm saying, well, it will be the section number 1 from the material concrete number 1. Here it's something which is specific for the C# what we are using. That's the material specified, because if I will, for example, go to the section, here you can see that I have dozens of properties which I can work with. I can fill, which I can fill or not. And if I will transmit all the dozens of the parameters, it could be heavy on a traffic. So I just need to pass a few parameters. Therefore, I'm using these special properties specified. That's because here I need to define the material. Also, I would like to define that it's parametric massive cross-section type of the parameterization, and I can also set the name, which is RM1 and parameters in SI units. So exactly almost the same naming as in the case of the RFEM. So I have material defined, I have section defined. What I need to do is to start defining some geometrical conditions as a node first and second node. So I will do it here. I'm defining node and its number. I can define the coordinates with the help of the 3D vector. I can also set the coordinate system for the node. I will do it for the node number 2 here. Because I'm using the RFEM, I can define the line so that it will be the straight line with the definitions node N1 and 2. I can also attach some comments, types, type for line, etc. And here I'll create a member with the help of the member class, where I'll say, well, the member has a number 1. It's constructed from line number 1, and it has some properties like the section and also the comment. If I will use the Erste, I will just say, well, the start node, end node, and that's it. So I have such an option to use with the line here. What I need to do is to define the nodal support, which will be on a node 1, on the starting node of the cantilever beam. So it's very easily done. I'm using the class called nodal support. Here I will use the spring, which is used for the removal of the translation of a support. Here I can use that, well, in the X direction, it will be positive infinity, which is mean that it's a halt. I cannot move my support in the X direction. The same, it will be in Y and in Z. Exactly the same I can do also for the rotations. So in effect, it's a fixed support. So let's do it. In this moment, what I did, I use the classes of Webservice to construct some objects. Currently, they are not yet in RFEM. They are just in the memory. What I will do now is that I will notify the model, my test model, that I will do some modifications. I can attach also the name of the modification, and here I'm setting the objects from my application to the RFEM. So I will set the material, I will set the section, node 1, node 2, line member, and I will set the nodal support. Here I have some try and catch block, because if I will do some mistake in my properties, so that something is, let's say, represented wrongly, then I'll get an exception, and I can catch the exception, write some error message, and then do what I need to do. Here everything seems to be okay, so I will just do the finish modification. Once I'll do the finish modification block, I have everything what I set between the begin modification and the finish modification. So material, sections, nodes, lines, whatever. So here you can see that I have the rectangular section, which name is R_M150 and 1000. So I finished the modification with it. So I'll do the same as Doku. If I would like to do the calculation, so I need to have a static analysis settings. I need to create some load case. So I'll do it exactly the same. And once I have the load case, I have the static analysis settings, I can run the calculation, which is done on the background. Once calculation is finished, I can do the same what Doku did in the case of the Python. So that means if I'm interested in all calculated results, I can do it. I can use the export result tables with detailed members results to CSV, or I can do it also to the XML. And what I'm doing now is that I will just read the text file test XML, which is stored here on some my, let's say, temporary path for it. And now what I will do is to let's say write all the informations into the console application. So let me do it. So here you can see that I have some output from the internal forces from load case LC1. We will see how it looks like. So I'll do the calculation, and here I have the results. The last step which I have here, it will close my my application, or so it will close my model. So I will just do it, and then I will run it once again, just to show you the result. And try to break it here and here. There is an I will enlarge it here. If you need to abort the connection between your application or between the client application and RFEM, you can do it here. You can click on the abort. The connection will be aborted, or you can also press escape and the connection will be aborted. It could be useful in the case that you are in the experimenting phase of the development of your application and you need to abort the connection because your application crashed, and you need to work also with the RFEM, so you can do it here. So I will break the connection, and here I'll just show that I'm using the self-wait, only the self-wait for the demonstration purpose. And if I will also show the results, so you can see here that I have them calculated, and there are some values which have been presented in the SE units, which means Newton meters. Here you can see it in the kilonewtons. So I will close this and stop this. So basically, this is what I would like to share with you. I can do also the same as I did for the Erste, that I will just switch it here into the Erste. Then it's slightly change the view in the IDE. Now I'm using the DL or the library for Erste. I can work with it. What I need to do is to be sure that here I have the right address for it. I can also open the Erste and go through to the same that it's in the options, program options here. To check the server port ranges, because if I would like to use, let's say, simultaneously RFEM and Erste, I need to differentiate also the port ranges because it will be the different URL address. That's it. What I wanted to demonstrate with such a example here. Let me briefly check it that there should be also the object browser, where I will try to find my my library. If I have it here, I'm quite lost. So let's do it differently through this. Basically, here you can see which options you can use for the application, and the same is also valid for the model. There is also one option which could be presented, because if I have running application, I can just type to the URL address box that it's localhost 8:8081 PSDL, and I can see the description of the requests and responses which are done on the background. I can use also some extensions like Whistler to see, and here you can see what methods also you can use for the application. And also, if I will ask him for get me an active model, so he will respond me with an URL. I can do the same, and here here I can get all the operations which I can do with the model clients. So if I would like to also, let's say, rapidly experiment or try something with web service, I can do it also in web browser, or I can do it also in some application which is used for an API testing, like Postman or SOAP UI, or some other extensions like Boomerang or other applications. And that's all what I wanted to show from my side. And I'm giving word back to Andreas.
Okay, thank you, Jaroslav, for your nice presentation. I take over the screen just a moment. Yeah, before we close the webinar, I would like to show you where you can find the trial version and the recording of today's webinar and the files and so on our website, dlubal.com. Here above, you can find the free trial version of RFEM 6 and RStab 9 with all add-ons, and you can also test the using of the web services and so on, scripting. Yeah, we offer the files and the recording, and you can find it here in the next days, news and events, webinars. That's today's webinar. And you will find the recording here in the middle, and the files here, the Python files, and then the RFEM files are already here. And then you can test and try it by yourself. Okay, then I have to say thank you for your attention. Thanks to my two colleagues for the nice presentations. We've got a lot of questions, a big interest from our attendees. That's very nice. When you close the webinar, there is a small survey with only 4 small questions. It's quite important for our quality management. It would be very nice if you answer these questions. Okay, then have a nice rest of the day. Take care and bye-bye.
Bye.
Bye, everyone.